So this unit we've been focusing on the different ways to solve systems. We can do it through graphing, through substitution, through elimination. And in this lesson we're focusing on the different types of solutions we could get. Now we've already learned that we can have one solution, that's what we've been working on, but it's also possible to have no solutions and this thing called infinitely many solutions. So if we look at this example, the system, y equals 5 halves x minus 2, or as always we can say plus and negative 2, and 2y equals 5x plus a negative 4, or minus 4, we could use any of the different methods to solve it. Obviously, since there's a graph here, I want to graph it. So let's look how we're going to solve the system, or what our solution to the system would be. So this first one here is in slope-intercept form. My y-intercept's a negative 2, so I'll plot that on my y-axis. My slope is 5 over 2, so I'm going to rise 5 and run 2. Up 1, 2, 3, 4, 5 over 2. And draw our line through that. Alright, and then the second one isn't quite in slope-intercept form because slope-intercept form needs to be solved for y. But we're close. If I divide each side by 2, 2 divided by 2 is 1y, and then I can divide each of these terms by 2. 5x divided by 2 plus a negative 4 divided by 2. So I'm left with y equals, I'll leave this as a fraction because it's my slope, 5 over 2x plus negative 4 divided by 2, which is a negative 2. So now if I'm going to graph this, my y-intercept is a negative 2, my slope is 5 over 2, so I'm going to rise 5, 1, 2, 3, 4, 5, and then I'm going to run 2, 1, 2. And we basically get the exact same line. We don't basically get it, we do get the exact same line, because if you look at my two equations, they're exactly the same. So even though they didn't start out looking exactly the same, they're equivalent. This equation here was equivalent to the first equation. So that means any number you put into this equation, it's going to work for both of them. So in that case, notice that, remember the lines represent solutions and they're the exact same lines, so all numbers are going to work. I shouldn't say all numbers. All pairings of numbers on this line are going to work. So in that case, what we say our solution is infinitely many, oops, if I can spell correctly, infinitely many solutions. Because any pairing that works for this blue line is also going to work for the red line, or the red equation. So there's infinitely many solutions because these lines go on forever. Let's look at another example that doesn't involve graphing. We have this system here, negative 3x minus 3y equals 15, and then x plus y equals negative 5. The way this is set up kind of leads me to want to solve this using elimination. I have a negative 3x here, and if I just multiply this x by 3, I would get its opposite. So I'm just going to multiply the second equation by 3. So I have my first equation, negative 3x plus negative 3y equals 15. My second equation, 3 times x gives me a positive 3x, plus 3 times y is a positive 3y, and 3 times a negative 5 is going to be a negative 15. Let's see what happens when I combine these. Negative 3 plus positive 3 cancels out. Negative 3y's plus positive 3y's cancels out. So on the left side of our equal sign, I have 0. 15 plus a negative 15, well, that equals 0 as well. Now this is a little different than the no solution. In the no solution example we did, we've got 0 equals 30. That's not true. But 0 does equal 0. So when you run into something like this where you have one side of the equal sign is the exact same thing as the other side of the equal sign, again, that's when we say there's infinitely many solutions. If we were to graph this, we would see that they're the exact same line. And again, when I multiply the second equation by 3, remember we can do whatever we want as long as we do it to both sides, we get basically the same equation, just its opposite. So if you ever get an equation where this side does equal this side, in this case 0 equals 0, then your solution will be infinitely many solutions. The way we solve systems doesn't change, whether we graph them, solve them using substitution or elimination. But we need to be aware that sometimes our solutions to these systems, yes, they will be one point that we've been working on, but it is also possible for there to be no solutions and infinitely many solutions.